Hi guys, we continue with example 5 still in capacitance chapter. So read the question. A series circuit consists of 0.05 microfarad capacitor, 0.1 microfarad capacitor and a 400 volts battery. So how many capacitor you have here? 2. C1, C2 and a 400 volts battery. So here will be the V voltage. Find the charge on final capacitor. So okay, now series, right? Series. How to calculate series? Series. So how to calculate series is 1 over C. So for example 5, now you have to find the charge, right? First, find the total or equivalent capacitance, which is 1 over C equivalent is equal to 1 over C1 plus 1 over C2. So C1 is 0.05 microfarad, C2 is 0.1 microfarad, substitute into here. So 1 over C equivalent is equal to 1 over 0.05 micro plus 1 over 0.1 micro. So C equivalent is equal to 1 over C. We total up the right hand side first. 1 over 0.05 micro plus 1 over 0.1 micro, like this. Okay, is equal to this answer. So no need to waste your time. So this is the answer, right? So how to find C equivalent? C equivalent up here, 1 over answer. So in your calculator, 1 divide by answer. So C equivalent is equal to 3.33 times 10 to the power of negative 8 farad. So here will be C equivalent for these two, okay, the total capacitance, because you are given 2 capacitor, but the question asks you find the charge on final capacitor. So you have to use C is equal to Q over V. C, this answer. Q, you have to find charge. Voltage given just now 400 volts. So 400 volts here. So what is the Q answer? Right? Answer will be in the bracket here. 1.33 times 10 to the negative 5 coulomb. That's the answer for A. For B is this one. Okay, for B, on final capacitor, okay, same question. Find the charge on final capacitor if they are reconnected in parallel. Just now the first step is in series, but now in parallel. Okay, just now that's how you calculate in series. Series. Okay, now we move to parallel. Parallel, how you calculate parallel? Just add all. So C equivalent, this one for B, is equal to C1 plus C2. C equivalent is equal to C1 just now 0.05 micro plus 0.1 micro. So answer 0.15 micro. C equivalent. So to find charge, C is equal to Q over V. C substitute into here. Q you don't know. Voltage just now given 400 volts. So Q answer this one, 6 times 10 negative 5 coulomb. Make sure you calculate, because some of you don't know how to calculate. Okay, this one is example 5. Now we move to example 6. Three capacitors C1, C2 and C3 with the values. Make sure you know 5 micro. 5 micro, if you don't have this calculator, 5 times 10 negative 6. Okay, micro is negative 6. but if you have this calculator, you just press 5 shift 4, 5 micro. Okay, C2 is 4 micro, C3 is 9 micro, are connected together. Find the effective capacitance. Effective capacitance, same meaning with the equivalent capacitance or total capacitance of the group if they are in parallel. So in this example 6, you just find the total capacitance, which is you want to use the first equation or the second equation if they are in parallel. If they are in parallel, please use parallel equation, which is this one. For B, if they are all in series, if in series, this is the equation. Alright, try to calculate yourself. So this is the answer. Okay, we will move to example 7. Example 7, find the equivalent capacitance of the group of capacitor in figure. This is the figure. Find equivalent capacitance. So, in this case, how many capacitor you have here? C1, C2, C3. So, how you find equivalent capacitance? Okay, in this case, you have more than 2. And it's a mix of parallel and series circuit. So we call as complicated circuit, okay, but actually it's not complicated at all. Okay, in this case, how you simplify the circuit? First, you see this one is parallel, right? So you combine up these two. How you combine? You have to calculate parallel equation, which is this one. Parallel, you just add all. So the first thing here, combine these two circuit and these two capacitors, which is C12. C12 means total of C1 and C2. So 4 micro plus 2 micro. So you will get 6 microfarad. Is this the total capacitance? Not yet. Okay. So after you combine, you will get this kind of circuit. Here is C12, here is C3. So C12 is 6 micro, C3 here is 3 micro, sorry. Okay, 3 micro. Here is the voltage. So total up these two. Why you total up or you simplify? Because you have to find equivalent capacitance. So for series, how you calculate? 1 over C equivalent is equal to 1 over C12 plus 1 over C3. So substitute the value. C equivalent is equal to this one. C12 is 6 micro plus 1 over 3 micro. So the answer is this one. Okay, for question B, find the charge on final capacitor. Final capacitor, it means a combination of capacitor, which is this answer, 2 times 10 negative 6 farad or 2 microfarad. Okay, so find the charge. How you find charge? It's so easy. You just use C is equal to Q over V. C is C total, which is this answer. Or if you calculate here, you will get the same answer with this. Okay. Q you have to find. V, how much V? Given 12 volts. So substitute here, you will get Q. Alright, clear? This is one of the simple example. Okay. Okay, next we will move to the last example, which is more complicated than previous one. It will contain 10 marks. So in this case, find the equivalent capacitance between A and B. A and B means the total capacitance. A and B, we will connect with the battery. If you have battery. Yeah, you have battery. 15 volts battery. Okay, find the equivalent capacitance. Now equivalent capacitance is so easy. You just simplify the circuit. You just use parallel equation or series equation. If you ask to find charge, you just use C is equal to Q over B. Alright. So find the equivalent capacitance. First thing first, you have to simplify the circuit. So in this circuit, how many capacitor you have? 1, 2, 3, 4, 5, 6. Right. So I just label C1, C2, C3, C4, C5, C6. Okay, which part you want to simplify first? Here, C5 and C6. Yes, you can. Okay, so in this case, how do you know it's parallel or series? Okay, very good. It's parallel because there's a junction here. If there's a junction, of course, between these two capacitor is the parallel. Okay, in this case, it's parallel or series? Very good. It's series because there's no junction of the wire. Okay, in this case, there's a junction. So between C12 and C3 is parallel. Okay, now we settle up C5 and C6. C5 and C6 is parallel. So how you calculate parallel equation? Parallel. What's the parallel equation? Parallel, you just add all. So C5 plus C6. So parallel C56 is equal to C5 plus C6. So C56 is equal to 2 micro plus 2 micro. So C56 is equal to 4 microfarad. So C56 you already combine. So after you combine, you will get this kind of circuit. Wait, okay, after you combine, you will get this one. C56, C4, C3, C1, C2. Okay, this kind of circuit. This one is a simplification of circuit. Okay, so how you simplify the circuit? Okay, you can simplify this one. It's series. Here also you can simplify series. So you calculate series. Series is 1 over C4, 5, 6 is equal to 1 over C4 plus 1 over C5, 6. So 1 over C4, 5, 6 is equal to 1 over C4. C4 given 4 micro plus C5, 6 just now. You calculate, you get 4. So C4, 5, 6 is equal to 1 over 4 micro plus 1 over 4 micro, 1 over answer, 2 microfarad. Okay, in this case, series use the same equation. 1 over C12 is equal to 1 over C1 is 4 micro plus C2 is 2 micro. So C12 is equal to 1 over 4 micro plus 1 over 2 micro, 1 over answer, 1.33 times 10 negative 6 farad. Okay, so you simplify this one, you combine, you will get 1 capacitor. You combine this one, you will get 1 capacitor. So we draw the simplified capacitor some more. This is AB. Sorry, here in the middle we have C3. So after you simplify, you will get C12 here. After you simplify, you will get C4, 5, 6. C12 just now, you will get this one. 1.33 times 10 negative 6. C456 is equal to 2 microfarad. C3 given just now, 6 micro. Okay, in this case, between C12 and C3, there's a junction, so it's parallel. Between C3 and C456, also there's a junction. Junction means the electron will move to left and right. Okay, so 3 of these are in parallel. So how to calculate parallel? Just add all. C equivalent equal to C12, this one, plus C3, this one, plus C456. You just add all because parallel, okay? C equivalent is equal to 1.33 times 10 negative 6, or micro, plus C3, 6 micro, plus C4, this one, 2 micro. So C equivalent is equal to 1.33 micro. .33 times 10 negative 6 farad. Okay, here will be the final answer. Here is the answer. Okay, same answer. So in this complicated circuit, please make sure you know how to simplify the circuit. Okay, so until example 8 will be our last example. So make sure in this chapter you know what is the function of capacitor. What's the function? The function is capacitor is to store charge. Okay, store charge. Just remember your handphone storing charge. If you don't have battery, you plug in the plug, you switch on, then the electron will move. You will store charge. Your capacitor in your handphone will store charge. Okay, so capacitor function is storing charge. So how to calculate capacitance? You have two equation, C equal to Q over V, and the other one is C equal to epsilon naught A over D. Epsilon is the permittivity between two space, okay, free space. So if you have more than one capacitor, so make sure you know how to calculate in parallel and in series. And of course, the unit of capacitance is farad. Don't forget that, okay? So in the next chapter, we will discuss about resistance. Similar to this case, to the capacitance, but capacitance is storing charge, right? How about resistor? How to calculate parallel and series resistance. So we'll see you in the next chapter, in the next video. Thank you very much.